Hello Cloud Gurus and welcome to Domain 6 of the AWS Certified DevOps Engineer Professional course, High Availability, Fault Tolerance and Disaster Recovery. You're almost there. This is the last module specified in the exam outline. This module comes in at about 16% of the exam, which is somewhere in the middle like the last module. However, there are a few more services to talk about here compared to the last one. We'll be talking about any service that can be used in a highly available way, and anything that can assist with fault tolerance and disaster recovery. This includes things like highly available databases, authentication, data storage, and backups. The finish line is in sight, so let's get started. Hello Cloud Gurus and welcome to this lecture on AWS Single Sign-On. What is it? Well, its name tells you a lot. It's a cloud service that makes it easy to manage single sign-on access to multiple AWS accounts and business applications. Let's go over a few of its features. It integrates directly with AWS organizations, which helps you easily manage access to all of your AWS accounts. It allows you to give single sign-on access to cloud applications, so you can easily manage access to them without any third-party solutions required. You can create and manage your users and groups in a tiered level of access based on user accounts or the group membership, all in the AWS console. And you can use existing corporate identities as well. You can integrate directly with Microsoft Active Directory through the AWS Directory service for easy setup. So let's talk about the relevance of AWS Single Sign-On to this module. It's highly available, of course. It's an AWS cloud service and high availability is pretty much the default. It's also fault tolerant. You aren't managing the hardware or the software here. You just have your console interface to SSO, so there's no risk of hardware or software failure that you have to deal with. That all happens behind the scenes at AWS and it's not something you have to worry about. Now, this is one of those services where you just need to know that it exists as an implementation option, so I won't be doing a demo for this one. I will, however, provide a resource link to a page where you can read a bit more in depth about the features that it offers. Okay, thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Amazon CloudFront. What is Amazon CloudFront? It's a fast content delivery network, or CDN, that securely delivers data, videos, applications, and APIs to customers globally. What this means is that it's a service that sits somewhere between your servers and the internet, where users that request your website content receive your website data from the server with the least latency to them, wherever they are in the world. Let's take a look at an example. We have our user and he's trying to access your website. So his DNS request is directed to Route 53 and the DNS entry points at your CloudFront URL instead of your load balancer or directly to your website. Behind CloudFront sits two different sources. The first is the static source, where your static images and CSS files live in an S3 bucket. And the more dynamic content, or the backup source where all of the requests go if they don't match the images or CSS defined by the static rule, or for the login page and anything in the admin directory, these are forwarded to an Elastic Load Balancer, which then accesses the instances actually hosting your website. Now CloudFront really shines when you have a lot of static content that it can keep on its edge nodes around the world that limits the access that it needs to your own servers. Your customers hit the CloudFront server and they get the content straight away and it doesn't have to flow all the way through to your load balancer. Now I don't want to bore you here with the slides as it's the concepts you should be learning here. So let's jump into the AWS console and I'm going to show you how to set up a very similar CloudFront distribution, but we'll use ACAT Guru instead. Okay, I'm in the EC2 console and I have an EC2 instance running. This has Nginx running and it's hosting my website. And you can see it here, and this image is broken, and that's intentional. Because what I want to do is I want that image to come from CloudFront, which is going to point it to an S3 bucket. Now you can see here my image is actually stored in an images directory as acattext.png. Now in some of my previous lectures, I've actually had the full domain here, which is acat.guru/acattext.png. I don't want to do that here. I want all of my images to come from an S3 bucket. So that's why I've changed that there. And this will demonstrate to us that CloudFront can pull resources from your server and from your S3 bucket, both at the same time using its internal rules. Okay, let's head to EC2. Now to make this work like our graph, I'm just going to create a quick load balancer. And we'll just do an application one. Let's call it CatGuru. Internet facing IPv4 port 80. Next. Target group, new target group. Let's call it a CatGuru. Port 80. That's all fine. And let's just register our one target. Now click add to registered and then next. Create. Load balancer CatGuru is successful. That's just provisioning. I'll give that a moment. Now, while we're waiting for that, we're going to head over to CloudFront. Now, we're going to create distribution in CloudFront. We have two options here. We've got the web, which is our standard web content distribution methods, and it speeds up distribution of static and dynamic content, for example, HTTP, PHP, and all those static files that I mentioned. There's also RTMP, which uses the Adobe Flash Media RTMP protocol, which allows you to do live streaming. We're not using that, so we'll click Get Started up here. Now we want to click Origin Domain Name, and hopefully our load balancer is here. And here it is, CatGuru. Excellent. Now we don't need an origin path. That's optional if you want to use a different directory in an S3 bucket, if you are using an S3 bucket up here. You can select your SSL protocols. We're not going to be using that. We're just going to be using HTTP. We can leave all these options fine. And we'll scroll down. You can even hook this up to Lambda if you like. You can hook almost anything up to Lambda these days. Now we have price classes. I'm just going to use the default, which is best performance. Now, if you're going to use other URLs to access your CloudFront, you can list it here. I'll just leave that default. It's going to put in its own CloudFront SSL certificate as well. And I'm going to click Create Distribution. We'll leave everything else as default. Now, this can take quite some time. In the past, it took me up to 20 minutes to get a CloudFront distribution created. So I'm just going to pause it here and I'll resume when it's done. Okay, my CloudFront distribution is now in the state enabled, so it's all working. What we can do now is grab this domain name and paste it into our browser, and we'll see what happens. Okay, excellent. I'm brought to my CatGuru website with the image still broken, and that's exactly what I want at this point in time. Okay, now we need to set up the S3 bucket. So click on your ID here, and we're going to create a new origin. And this is going to be straight to my CatGuru S3 bucket. Everything else here can be kept as default, and we'll click Create. Now what this is going to do is it's going to give us an S3 bucket as another source for where we're going to be able to get content from to deliver out via CloudFront. Now that's probably over here running. It's already in progress and it's updating. But while that's updating, we can also come over here and configure our behavior. So we want to create a behavior. And we're going to give it a path pattern of images /*. So this means any image that we're going to access via the path images, we want to grab it from the S3 bucket instead of the Elastic Load Balancer. Everything else as default should be fine, and we'll click Create. Okay, and we also have precedence here. So the images path has to be first, otherwise everything is just going to hit default. And it's never going to try and use our S3 bucket to access the images. So the default behavior is good, and we'll leave it as that. Now we'll go back to General. Actually, we'll go back to CloudFront Distributions, and we're going to wait until the status is done, and then we'll test this out. So I'll pause it again. This can take some time, and I apologize for how long it takes. That's just the nature of CloudFront and getting everything working worldwide, because there's nodes everywhere, and it needs to make sure they're all updated at the same time. So we'll be back in a moment. Okay, we are deployed. So in here, that means anything going to images should hit our S3 bucket instead. So let's take a look and see if it works. So this was our broken website. If I click refresh, we've got our image. Awesome. And if I open this in new tab, we can see that it is going through CloudFront. It's going /images and then acat text. So in the interest of completion, I'll show you the S3 bucket. We've got the ACAT Guru. Actually, this images folder isn't being used, so I can delete that. And it's just pulling this ACAT text.png. I also serve this directly out of S3 using S3's web server. That's why all the files are here, but it's just pulling the image from here. So if I go and refresh this, the image will still be there, and same with this one. So that's how it works. That's how CloudFront can pull images from S3. You can pull pretty much anything you want from S3 or from your load balancer or from any other origin that you set up in the origin section. Okay, so that's pretty much all I wanted to show you here in how CloudFront works. Make sure you delete your behaviors before you can delete your origins. Actually, maybe we can just delete this whole distribution without going through all that. Nope, we can disable it, but we can't delete it. So I'll go here, delete this one, delete this one, can't delete it. Maybe we just need to disable it first before we're able to delete it. So again, it can take up to 15 minutes to disable it, and then it'll probably give us the option to delete it. All right, thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture where we're going to discuss autoscaling and lifecycle hooks. If you've come as far as the DevOps Professional course, I don't doubt for a second that you already know what AWS EC2 autoscaling is, but I'll mention it briefly anyway, as a reminder is always good. AWS EC2 autoscaling allows you to scale your instance capacity automatically according to your defined conditions. You can increase the amount of instances you have running during demand spikes and decrease them when you don't have any load. It's not only for high availability, but for cost saving too. So here we have our autoscaling group in which our instances will be attached. We have our minimum size, which is 1 instance. We always need to have at least 1 instance running. We have a desired capacity of 2. This is the amount that we want running. You can use CloudWatch alarms to modify this value based on any data you're tracking, such as overall CPU or RAM usage. We can scale out as needed until we hit our maximum size. This is the most instances we'll ever have running in our autoscaling group. So this of course results in higher availability as you're scaling automatically, and your service should never be unavailable to your customer. It has better fault tolerance as your service will be distributed over multiple servers instead of a single point of failure. And you also get better cost management where servers won't be used if there's no demand for them. You just pay for what you require at any point in time. Alright, so that summary shouldn't be anything new, but if you've only done the associate exams, I'll be introducing a new subject here called the autoscaling lifecycle. There's 3 things to remember about the autoscaling lifecycle. Firstly, it starts when the autoscaling group launches an instance. It ends when you terminate the instance. And it also ends when the autoscaling group takes the instance out of service and terminates it. So let's see what it looks like. So we start with our autoscaling group. The autoscaling group will get a request to scale out. Whether you manually increase the size of the group, a scaling policy automatically increased it due to demand, or a scaling schedule increased the group size at a specific time. Your instance will then be in a pending state. Between pending and the instance coming into service, it comes in contact with a lifecycle hook called EC2 instance launching. After completing these hooks, the instance will now be attached to the autoscaling group and it enters the in-service state. This instance is now counted against the desired capacity of the autoscaling group. Now an instance will remain in the in-service state until one of 4 possibilities occurs. If a scale event occurs, or if your system fails a health check, the instance will enter the terminating state. This then calls another lifecycle hook for terminating, called EC2 instance terminating. Once it goes through terminating wait and proceed, your instance is then terminated. You can also put your instance into a standby state. This enables you to remove instances from service, troubleshoot them or change them, and then you can put them back into service. Instances in this standby state will continue to be managed by the autoscaling group, but they won't receive traffic as they aren't an active part of your application until you put them back into service, where they enter the pending state and then back to in-service. Now the final way an instance can leave the in-service state is if the instance is detached from the autoscaling group. So it goes to detaching, then it's detached. After it's detached, it returns to being a standalone EC2 instance, which can be managed separately from the autoscaling group, and it can then be reattached to the same or a different autoscaling group if you like. So what's the point of all this? Well, it's the two lifecycle hooks that we have here. The lifecycle hooks allow you to implement custom actions as autoscaling launches or terminates your instances. So during pending wait or terminating wait, you can trigger something that would install software on a newly launched instance, or to copy logs from an instance before it's terminated. So let's talk a little about how that would work. So I'll briefly explain the process if your autoscaling group wants to scale out and add a new instance. So autoscaling responds to the scale out event by launching your new instance. It then puts the instance into the pending wait state. Autoscaling then sends a message to the notification target defined for the hook, along with information and a token you can use to control the lifecycle action. In this state, it waits until you tell it to continue or the timeout ends. So you can now perform your custom action. You can install software and so on. Now by default, the instance will wait for an hour and it will change the state to pending proceed, then it will enter the in-service state. If you need more time, you can restart the timeout period by recording a heartbeat, or you can change the default wait time. So I've got a few notes about lifecycle hooks for you. As I mentioned, you can change the timeout for the lifecycle hook, and you can set the timeout when you create the hook by using the heartbeat timeout parameter if you're using the CLI. You can call the complete lifecycle action command to tell the autoscaling group to proceed. You can call the record lifecycle action heartbeat command to add more time to the timeout. If you have a 60-minute timeout and add 30 minutes, this will add it so your total will be 90 minutes. And finally, 48 hours is the maximum you can keep a server in wait state, regardless of the heartbeats that you keep adding. When autoscaling launches or terminates an instance due to a simple scaling policy, a cooldowner takes effect. The cooldown period helps ensure that the autoscaling group does not launch or terminate more instances than are needed. Cooldowns start when the instance enters the in-service state, so if an instance is left in the pending wait state as you perform functions on it, autoscaling will still wait before adding additional servers. At the conclusion of a lifecycle hook, an instance can result in one of two states, abandon or continue. Abandon means your additional actions taking place failed, and it will cause autoscaling to terminate your instance and, if necessary, launch a new one. Continue means your additional actions were successful, and autoscaling will then put your instance into service. A couple of notes about spot instances. You can use lifecycle hooks with spot instances, but it doesn't prevent an instance from terminating due to a change in the spot price, which can happen at any time. In addition, when a spot instance terminates, you must still complete the lifecycle action. Alright, I'll finish up here. That should be all you need to know about lifecycle hooks for the DevOps exam. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Route 53. Similar to some other topics in this module, you most likely have heard and have used Route 53 before. So this lecture will just be a reminder of a few of the features and how they're relevant to the DevOps exam. So Route 53 is a highly available and scalable domain name system or DNS service. Let's go through some features. Amazon Route 53 is highly available DNS. Built using AWS's highly available infrastructure, DNS is distributed around the world, and Amazon state that they will use reasonable efforts to make sure Route 53 is 100% available. They actually have a service level agreement stating if Route 53 isn't available for 5 to 30 minutes, you'll get 1 day of free service credit. If it's down for 31 minutes to 4 hours, you get a week of service credit. And if it's down for more than 4 hours, you get 30 days of service credit. That's how confident they are in Route 53 being highly available for you to use. Next, it interfaces directly with EC2 and S3. You can use your EC2 load balancers and S3 buckets as a target for DNS records that you're creating in Route 53. And it makes you and your applications fault tolerant. It does this by providing various ways to ensure your application is available, and it provides multiple routing types to ensure your customers get the best experience possible. As I mentioned, the real fault tolerance in Route 53 comes from how you configure your routing policies. Now, besides the simple routing policy, which is a default assign an IP address to a domain policy, Route 53 has 6 other policy types that you're able to implement. We have the failover routing policy, which is used for an active-passive failover. If your primary resource is unhealthy, Route 53 will reroute the users to a healthy resource. This could even be a backup S3 bucket when your website goes down. We have the geolocation routing policy, which lets you route traffic based on the location of your users. For example, you might want all of your Australian users to be directed to your load balancers in the Sydney region. We then have the geo-proximity routing policy, which only works when you're using a Route 53 feature called traffic flow, which I'll talk about in a moment. This lets you route traffic to your resources based on the geographic location of your users and your resources. You can also introduce your own biases, which expands or shrinks the size of the geographic region that you want to route your traffic to. I'll walk you through a demo of this shortly. We also have the latency routing policy, which routes users to the region that provides the best latency. We have the multi-value answer routing policy, which will randomly route to up to 8 destination resources. And we have the weighted routing policy, which is used to route traffic to different resources using a percentage split. This is useful when you're A/B testing and want to test how traffic works to different versions of your application. Okay, now there's a link in the resources section of this lecture called Routing Policies, which goes a bit deeper into each of these if you'd like to learn more, and I suggest you at least read through it once to learn the differences between them all. Okay, now I'm going to head on over to Route 53 in the AWS console, and I'm going to try and implement the geo-proximity routing policy, which is the one I have most trouble explaining here, so a demo should clear it up. Let's head on over. Okay, let's head to Route 53, and we're going to go to traffic flow and look at traffic policies. That's a quick image of what it looks like, and the traffic flow visual editor lets you create your sophisticated routing configurations. So let's create a traffic policy. Let's just call it geo policy. We'll click next. And now we're in this traffic policy creator interface. So I'm going to use DNS type, which is just an A record. I'm going to connect to, and we're going to use geo proximity rule. Now we can pick the endpoint location. I'm just going to say North Virginia, and we're going to connect to a new endpoint, and I'm going to connect that to S3. So if someone is near US East, which is in North Virginia, they'll be redirected to my S3 website endpoint, which is ACAT Guru. I'm just going to use S3 because I've already got these set up and I don't have to do load balancers and things like that. Now for our second one, let's use Ireland in the EU. Similar thing, new endpoint, and this time I'll give it a dog guru. And then I'll add one last one if you're in Australia. So we use Sydney, new endpoint, S3, and you'll get a pet guru. And another thing you can do here is you can show your geo-proximity map based on what I've just created. So it's generating this map now for us to have a look at. Should appear in a moment. And this is how our traffic is going to be split based on where you are in the world. See if we can zoom out a bit. That's it. So Sydney is going to 3. The island is going to be 2, and 1 is the North Virginia. So that's kind of cool. You can visualize where your traffic is coming from and where it's going to be routed to using these geo-proximity rules. You can see here we also have this bias option. So you can actually increase this. If I go 30, it's going to increase this blue area. So it'll give a bias to this area. So if you want more people in the Americas to be weighted towards this rule, you can increase that. If you want less people, you can even go -30. It goes from -99 to 99. So that makes it a lot smaller, giving more precedence to routing 2 and 3 options that we set up. But we'll just keep that as 0. And then we can create traffic policy. So it's called geo policy, And we've got all this done. Now what I might do, you can create a DNS name here. Actually, I might not create a DNS name because this is going to be $50 a month for each policy record that you create. So what you could do here is set up your www website, acat.guru, and based on where someone is visiting it throughout the world, it's automatically routed to your S3 buckets. You could have different load balancers for different regions, and they're going to get a nicely routed website. It's going to be quick because it's going to be the load balancer that's closest to where they're from. So that's how that routing policy works, and I hope you now understand it a bit clearer. All right, thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on, and we can come in here and delete this policy just so it's gone. Okay, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Amazon RDS. Again, another topic you have most likely covered in detail for previous AWS exams, but I'll give you a nice refresher in this short video. RDS stands for Relational Database Service, and it lets you create, run, and scale relational databases in the cloud. They're fast, with sizes up to 128 vCPUs and 3,904 gigabytes of RAM available. They're cost efficient and resizable based on your needs, and they can run in private VPCs and can be encrypted so they are secure. And they can be highly available if you require them to be, and there's minimal administration required on your behalf because it's a managed service. RDS currently supports 6 different database engines. Depending on your region, not all of them may be available. You can of course use MySQL, MariaDB, Microsoft SQL Server, Postgres, Oracle, or Amazon Aurora. I mentioned earlier that RDS has minimal administration requirements, and I'd just like to go into a bit more detail here regarding what AWS will look after for you. It will provision the infrastructure capacity you request and install the database software. It'll perform the backups automatically. It will patch the database software. If you require a multi-availability zone deployment, it will also manage synchronous data replication and automatic failover. You are still responsible for database settings specific to your application, your schema, and any performance tuning that you require. RDS can be both vertically and horizontally scaled. Vertical scaling refers to changing the instance type to increase server capacity. With RDS, you can range from the smallest T3 micro at about 2 cents an hour, all the way up to the R5 24 extra large, which comes in about $11.52 an hour. You simply have to find which database type fits both what you're doing and your budget. Of course, there's also discounts if you're willing to commit to a long-term use of the database, which can add up to hundreds or even thousands of dollars saved over a 1 or 3 year period. You can also scale your database storage live while the database is in use, except for Microsoft SQL. So keep that in mind. If a question ever refers to scaling storage in Microsoft SQL Server, it can't be done. Now, RDS can also scale your databases horizontally using read replicas. These are read-only copies of your database, which are constantly being kept in sync with your master database. This helps increase availability. It can produce higher performance as your replicas can be in a different region closer to your users, and they can help with a faster recovery as you're able to promote a read replica to a master if required for disaster recovery. And finally, you can also create a read replica of a read replica if you want to. And this helps with spreading your database load around so your primary database isn't overloaded due to heavy use. Alright, that's about all I'll talk about for RDS now. In the resources section of this lecture, I've added a link with a quick blog post which will be great for you to have a look at, so please do. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Amazon Aurora. Amazon Aurora is a MySQL and Postgres compatible database built for the cloud. I mentioned it briefly as one of the database engines you can pick in RDS, and this lecture will give you a bit more information about it, specifically because it's made by Amazon and mentioned a few times in the exam. Amazon Aurora is a relational database engine that is as fast and reliable as high-end commercial databases, but also simple and cost-effective as open source databases that you may be used to. It can deliver up to 5 times the throughput of MySQL running on the same hardware, and it's completely compatible with MySQL 5.7, meaning it can be used as a drop-in replacement for anything that uses MySQL. Aurora's storage is fault-tolerant and self-healing. Disk failures are repaired in the background without loss of any database availability. It detects database crashes and restarts without the need for any kind of crash recovery or database cache rebuilding. And if the entire instance fails, it will automatically fail over to one of up to 15 read replicas. And finally, it supports storage auto-scaling. You can start with a database of 10 gigabytes and have it automatically grow up to 64 terabytes without any availability disruption to resize or restripe your data. So let's talk about backups. Aurora's backup capability provides automatic, continuous, and incremental backups, which enables point-in-time recovery for your database. This allows you to restore your database to any second in your retention period up to the last 5 minutes. The backup retention period can be any time up to 35 days. Backups are stored in S3, and the backups themselves have no impact on database performance. Now let's talk about snapshots. Like other services, Aurora supports user-initiated snapshots, which are stored in S3. They're kept until you explicitly delete them, and they're incremental, which saves time and storage. Regarding database failure, Amazon Aurora automatically maintains 6 copies of your data across 3 availability zones. Due to this, in the event of a database failure, it will attempt to recover your database in a healthy availability zone with no data loss. If this fails, as mentioned earlier, you have your point-in-time or snapshot restore capability as well. Aurora has a lot of fault tolerance built in. Your data is divided into 10 gigabyte segments, which are spread across many disks, which transparently supports the loss of up to 2 copies of data without affecting your ability to write, and up to 3 copies can be lost without affecting your read availability. Aurora storage is self-healing, and data blocks and disks are continually scanned for errors and are repaired automatically. Now, Aurora supports 2 kinds of replicas, the first being Amazon Aurora replicas, which share the same underlying volume as the primary instance. This means that updates made by the primary are immediately visible to all replicas. You can have up to 15 Aurora replicas. The performance impact on your primary database is low, and your replica can act as a failover target with no data loss. The second kind of replica Aurora supports is MySQL read replicas. Using these, the primary instance data is replayed on your replica as a transaction, and you can have up to 5. However, the performance impact on your primary database is high. And your replica can also be a failover target, but it may potentially have minutes of data loss. As always, Amazon are focused on keeping your data secure. All Aurora instances must be created in a VPC. SSL AES 256 is used to secure your data in transit. You can encrypt your databases using keys that you manage using AWS KMS. Your data stored at rest in Aurora's underlying storage is encrypted, as are all of its automated backups, its snapshots, and its replicas. And one thing to note here is that you can't encrypt an existing unencrypted database. You'll have to create a new database with encryption enabled and migrate your data to it. So that's just a bit of an overview of the Amazon Aurora database. It may come up in your exam. I'm pretty sure it was an option in a few of my questions, so it's good to know a little bit about it and its features. And finally, I'd like to discuss connection management in Aurora, namely the different kinds of endpoints that it offers. I had a question about this in the exam, so it's definitely something you should take note of. Aurora has different endpoints which you can use for different purposes when connecting to your database. So firstly, there's the cluster endpoint, and this connects to the primary database instance for your database cluster. And this is used for all write operations such as inserts, updates, deletes, and changes to your database configuration and schema. Then there's the reader endpoint, which provides a load-balanced connection to your database cluster, and as it mentions in its name, it's for reading. In fact, it's read-only. So you can use this to spread the load amongst all the read replicas, and you're able to reduce the load on your primary database by using this one as well. There's also a custom endpoint, which represents a set of database instances that you choose, An Aurora database cluster has no custom endpoints until you create one, and you can create 5 of them. And this lets you do things like provide a custom endpoint to a group of users who need to generate reports, and in that cluster you might have a bunch of low latency instances, while all of your production traffic is hitting a different high capacity instance. And finally, there's the instance endpoint, which lets you connect to a specific instance in the cluster. And this gives you a more fine-grained load balancing capability, which you can design yourself by assigning particular endpoints to your application, in which the other endpoints I've mentioned already on this page don't suit. Okay, I'll finish up this here. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on DynamoDB. I think DynamoDB only appeared a few times in my DevOps exam, so I won't go as deep as I used to for the old exam, but I'll still cover everything that you need to know. DynamoDB is a fully managed NoSQL database that supports key value and document data structures. So being a NoSQL database, it's a little different to a relational database, so there's a few different things to learn about. So as I mentioned, it's a fully managed NoSQL database service. If you haven't come across NoSQL database engines before, I highly recommend you stop this lecture and do some personal research on the differences between SQL and NoSQL. While detailed knowledge isn't required, the base concepts will make this section of the course much easier. DynamoDB also provides a fully performance, capacity, and scalability managed platform where all three can be managed automatically or via performance controls available to DevOps engineers as yourself. So what does this mean in practice? Well, there are no servers, and the concept of underlying storage and compute is abstracted away from the user. DynamoDB automatically allocates more as required. There are no practical storage limitations. This isn't 100% true, but for data storage purposes, you don't have to pay much attention to the raw data amounts being input into DynamoDB, as it's all handled automatically. It's fully resilient and highly available. DynamoDB is resilient to availability zone failure, and data is replicated across multiple independent data centers. When you access the data, you use a HTTPS endpoint, so a hardware or data center failure will be transparent to your applications. They won't notice any issues, and you won't notice any issues. It'll just continue to work. Performance scales in a linear way rather than jumping in a stepping way as you add servers. And you specify how many reads and writes you want per second on a per table basis, and the system handles the rest. It's fully integrated with IAM, so it allows controlled granular access, including federated and web identity, and this makes it perfect for mobile and web application usage. Now let's have a look at how the platform is structured. We'll start at the top. DynamoDB is a collection of tables. Tables are the highest level structure within the database, and it's at the table level that performance is controlled and managed. Now within DynamoDB, there's a concept of performance units. You specify the number of reads or writes per second to the database table, and if you go above these, you start becoming throttled. So we have the write capacity units, or WCU, and they're the number of writes of 1 kilobyte blocks per second to your table that you want. A 2 kilobyte write would use 2 units, a 500 byte write would use 1 kilobyte as the minimum. Read capacity units, or RCU, are the number of 4 kilobyte read blocks per second. As with writes, an 8 kilobyte read takes 2 units, and a 2 kilobyte read will take the whole 1 unit. DynamoDB uses the WCU and the RCU values and the amount of data stored in each table to manage the underlying performance. And one last concept at the table level, a relational database such as MySQL requires that the data structure be defined at the table level and that all rows within a table conform to this structure. DynamoDB does not do this, and this is where some of its flexibility and power comes from. So let's talk about the data structures within a table. A table, as with SQL and other database technologies, is divided into rows. Using DynamoDB terminology, each of these rows is referred to as an item. Each item contains a number of elements, and it's important at this stage to mention that each row can have a different number of elements or different elements. This is one of the key elements of DynamoDB, where it gains flexibility over SQL database technologies, where the data structure or schema is locked in at the table level. The individual elements are referred to as attributes. There are, however, a number of these attributes which are special, specifically at least one and possibly two. The first is the table's partition key. On its own, this attribute has to be unique in the table and is used to uniquely identify a row or an item, and is used when you want to retrieve the data using the query operation. The query operation is supplied with the partition key, and it retrieves the row or the item. The second special attribute is called the sort key, and this is used in a number of situations. An example would be if you've got an application storing temperature readings from many weather stations, the partition key would be the weather station ID, but how would you store multiple readings? Using the sort key, you can use a one-to-many relationship, and secondly, it can provide sorted items, so based on a time or a date. Additionally, the query operation can pull a range of values back using the sort key. And finally, just a reminder that the row or the item can have a different number or a different set of attributes. Now let's go and have a look at the attribute types. At a high level, there are two groups, scalar types and DynamoDB data types, which can hold single item values such as a string, a number which can be positive or negative, binary with base 64 encoding, which is useful for storing limited quantities of data. You can store Boolean values, which is true or false. You can have a literal null. And additionally, we have DynamoDB items such as document, which consists of arrays, lists and maps, allowing it to store complex JSON documents, and sets, which are arrays, a type which allows simple list storage. Alright, I'll finish this introduction to DynamoDB here. I only had one question dealing with DynamoDB when I sat the exam, but it's still an important topic you should learn about. So in the next lecture, I'll expand just a little bit more on the keys that I mentioned here, as they'll be the most important thing to learn for the exam. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on DynamoDB keys and streams. When you create a DynamoDB table, in addition to the table name, you need to specify the primary key of the table. The primary key uniquely identifies each item in the table, and you should also remember that an item is a row of attributes. Now, because they uniquely identify the items, no two items can have the same key. DynamoDB supports two types of primary keys. The first is a partition key, which is composed of one of the attributes in the database. Attributes are similar to fields or columns in a normal relational database. Here we have the product ID as a possible partition key. Now, as I said, if we're just using a partition key, they must be unique. So using a product ID as the partition key is suitable because product IDs are usually unique in a database. The second type of primary key is to use both a partition key and a sort key. Together, these are referred to as a composite primary key. This uses two attributes, and in our case, it'll be the product ID as well as the type, used together make up the primary key. Now, it's probably a good time to mention that DynamoDB uses the partition key value as an input to an internal hash function, and the output of this function determines the partition or the physical storage inside DynamoDB where the item will be stored. And all of the items with this same partition key value are stored together. And they're sorted by the sort key value. So it's possible in a table that has a partition key and a sort key that the table has two items with the same partition key value. This is okay, but they must have different sort key values. And just for completion in this graph, here's some more items. Okay, let's move on to some other names to remember. The partition key of an item is also known as its hash attribute. The term hash attribute comes from the use of that internal hash function that I just mentioned, which distributes the data across partitions based on their partition key value. The sort key of an item is also known as its range attribute. The term range attribute comes from the way DynamoDB stores items with the same partition key physically close together in sorted order by the sort key value. Next, I'd like to talk about secondary indexes. A secondary index lets you query your table data using an alternate key. You can create one or more indexes on a table, And once created, you can query the index like you do from the table. There's two kinds of indexes. There's a global secondary index, which is an index with a partition key and a sort key, which can be different from those on the table. And a local secondary index, which is an index with the same partition key, but a different sort key from those on the table. Before I finish up, I also want to mention DynamoDB Streams. DynamoDB Streams are an optional feature which captures data modification events in DynamoDB tables. Data about the events appear in the stream in near real time and in the order that they occur. Each event is represented by a stream record when a new item is added to the table, an item is updated, or an item is deleted. And you can also trigger AWS Lambda when a particular event appears in the stream. A great example here is automatically sending an email to a new customer. You could configure a Lambda function which will execute when the stream record appears. And you can make it process only when new items are added to the customer table. Then when an item has an email address attribute, Lambda can invoke Amazon SES to send an email to that address. Alright, so that's all about DynamoDB keys and streams. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture.